Here's the solution for day 2. The breaking strength Y in tons for a steel cable of diameter D inches is given by, and here's a table of values that would have been obtained experimentally when engineers tested cables of different diameters and measured how many tons of weight the cable can hold until snapping. Now from that data, the engineer could then calculate an algebraic expression that models the general breaking strength based on the size of the cable. So let's bring the calculator on screen and push Stat, Choice 1, Edit, and enter in the values of D for list 1 and the values of Y for list 2. I've already got those in my calculator. Now we want to look at the scatter plot. So second, Stat plot, and choose the first plot and turn it on. Then push Graph. It graphs the plot, but if nothing shows up, it's because we need to zoom to the plot. So zoom, and then choice 9 was zoom stat. Now we can see the data. A straight line would model the dots fairly well, yet it does look like it has a slight uphill curve, so an exponential function is a better model than a straight line. We're asked to duplicate that scatter plot onto our paper. So let me move the calculator over and then copy that graph the best that I can. To be accurate, try to visualize this window in sections. For instance, in your mind, imagine it cut in half or even cut in quarters so that you can properly position those 3 dots in the bottom quarter of the view. And then these 3 dots are more like the top right quarter, correct? And so here and here and here. You want to position these dots as accurately as you can to match what your calculator shows. Now we're asked to find the exponential function for this. So we'll have the calculator calculate that. Push Stat, go over to Calculate, and go down to the exponential regression, which is the choice 0. Scroll down to the word Calculate and push Enter. It gives us the general pattern to follow and tells us what numbers to replace in for A and for B. So the exponential function is y equals, in place of the letter A, we're supposed to put 4.75 if you round it. And then it gets multiplied by B, which is 6.77, again, if you round it. And then it shows us that x is the exponent. So here on paper is the exponential function that the calculator has calculated for us. What this equation models is the best fitting curve that would go through the dots.